structural engineers also responsible for selecting the material systems of that building. And that's a critical decision. I'll tell you why. If we have tariffs on steel coming out of a country, let's say now Canada or China, the cost went up. So is it more accretive to use a different material that's local, right? So the point being is they now have to have an understanding of the different materials and the impacts of the cost on those materials, right? So now, concrete, what's that great for? Great for mass, stiffness, and the fire resistance, right? Because in high density urban areas, we have massive fire codes. We can't allow fire to spread. Concrete is amazing at that because it's a non-combustible material. How about steel? Where do we see steel? Long spans, right? Because we can create these trusses, which are these massive sort of webs in our beams in order to span huge distances to have less columns, right? Where would you want that? Retail, at an arena, a theater, right? And how about this? Speed of construction. You get shop drawings for steel and they get manufactured elsewhere, so it should be like Legos and an erector set. Is it always like that? No, but it should be. And it's flexibility. You can change different shapes of steel that still have structural components to it. What else? Then we got light gauge framing. You're not going so high. So you want light gauge. What's light gauge? It's cold rolled steel. It's manufactured steel. It's not hot. It doesn't have to go through liquids into a liquid form and then get solidified. It's called cold rolled steel. Now that's good for mid-rise buildings, right? You're not going that tall. It's easy, it's lightweight, gets erected right in the field. And then last, we got this new, and we're seeing it all over New York and elsewhere in the Midwest, timber construction, increasingly popular for sustainability and aesthetics, right? Always looks fresh, it looks dope, but let me tell you something, more expensive. So this is the point. Each material has a different property. They're responsible for understanding the economics, what its capacity is for structural weight and its ability to carry specific loads, and its availability in that moment. So it gets a little bit more complicated. The structural engineer isn't just a mathematician.